Classes. Introduction to classes. JavaScript is an object-oriented programming (OOP) language we can use to model real-world items. In this lesson, you will learn how to make classes. Classes are a tool that developers use to quickly produce similar objects. Take, for example, an object representing a dog named Haley. The dog's name, a key, is Haley, a value, and has an age, another key, of 3, another value. We create the Haley object below. Let Haley. So Haley is equaling an object, and the object has name Haley, behavior 0, get name is a get on a method that returns this .name. Get behavior is a get on a method that returns this .behavior. Increment behavior is a method with no get or set, anything like that. That's just this .behavior ++. Now imagine you own a dog daycare and want to create a catalog of all the dogs who belong to the daycare. Instead of using the syntax above for every dog that joins the daycare, we can create a dog class that serves as a template for creating new dog objects. For each new dog, you can provide a value for their name. As you can see, classes are a great way to reduce duplicate code and debugging time. After we lay the foundation for classes in the first few exercises, we will introduce inheritance and static methods, two features that will make your code more efficient and meaningful. Instructions. In the next exercise, you will learn about classes in greater detail. Before you do, take a moment to study the class in main.js. Spend some time identifying the similarities and differences between the dog class in main.js and the code we use to create our Haley object in the instructions above. So we have a class, dog, and it looks like it opens up an object, but of course it's opening up a class. There is a constructor in the dog class. The constructor takes name, and this .name is equal to that name, and this .behavior is going to be set to 0. There is a getName method in this class that returns this .name. There's a getBehavior method that returns this .behavior. There's an incrementBehavior method that returns, it doesn't return, it just goes to this .behavior and increments it upwards, this .behavior ++. Let's just click run, and then we could keep moving. Yes, it can. Okay. 2. Copy the class instantiation method call and console.log statements below into main.js. Okay, so we need to copy all of this. Let's just copy it. And below the dog class, so after everything's done, we'll paste this in, and let's run this and see what happens. Okay, so we have a new const. Haley is a new dog, so it inherits everything from here. We're going to console.log haley.name, so we know haley.name is going to be the name that was passed in, which is Haley here, and that's what comes up. Console.log haley.behavior, we know that that is equal to 0, and nothing is passed in for it, so it should be 0. That is 0. The next is haley.incrementBehavior. That adds 1 to behavior, and it doesn't print it, so let's move on from there. Console.log haley.name, and it prints Haley again. I wonder why that's there twice. And then we'll console.log haley.behavior, and now that's at 1 because we incremented it before we checked the name yet again. And that's how that's working. Let's go to the next lesson. Constructor. In the last exercise, you created a class called dog and used it to produce a dog object. Although you may see similarities between class and object syntax, there is one important method that sets them apart. It's called the constructor method. JavaScript calls the constructor method every time it creates a new instance of a class. Class dog opens up an object, and constructor name And it just shows us what we had in the last one, where the name is going to be this.name and this.behavior is going to be 0. Dog is the name of our class. By convention, we capitalize and camel case class names. JavaScript will invoke the constructor method every time we create a new instance of our dog class. This constructor method accepts one argument, name. Inside of the constructor method, we use the this keyword. In the context of a class, this refers to an instance of that class. In the dog class, we use this to set the value of the dog instance's name property to the name argument. Under this.name, we created a property called behavior, which will keep track of the number of times the dog misbehaves. The behavior property is always initialized to 0. In the next exercise, you will learn how to create dog instances. Instructions. Create an empty class named surgeon. All right, so class, the word surgeon, and that's capitalized like they said. You should capitalize these, and we just open up that object there. Let's run that. Inside of the surgeon class, create a constructor method that accepts two parameters, name and department. So we need a constructor here, and let's look back at it before we do it so we can see exactly how they did it. So the constructor works just like a method. We're going to pass it name, it's going to set the name, and it's going to initialize behavior as well. I'm not sure ours does that, but that's what a constructor looks like. So let's do that. We will write constructor. And we will give it name. We do need to give it name, and we also need to give it department. And that's it so far, so let's just run that. Inside the surgeon constructor, create name and department properties and set them equal to the input parameters. So here we'd be saying this.name equals name, and this dot, what was it? Department, right? Department equals department. And I imagine we comma between them. Nope, we make them separate statements. So we end them with semicolons. Cool. And let's run that. Great, that works perfectly. This is our surgeon constructor. Let's move to the next lesson. Instance. Now we're ready to create class instances. An instance is an object that contains the property names and methods of a class, but with unique property values. Let's look at our dog class example. Class dog has a constructor that has name, this.name is name, this.behavior initializes to 0. Now, below that is the const Haley equals new dog, capital dog. And it passes in Haley as a string, which creates a new dog instance. So we console.log Haley.name, and that should log the name value saved to Haley, which outputs Haley. Below our dog class, we use the new keyword to create an instance of our dog class. Let's consider the line of code step by step. We create a new variable named Haley that will store an instance of our dog class. We use the new keyword to generate a new instance of the dog class. The new keyword calls the constructor, runs the code inside of it, and then returns the new instance. We pass the Haley string to the dog constructor, which sets the name property to Haley. Finally, we log the value saved to the name key in our Haley object, which logs Haley to the console. Now you know how to create instances. In the next exercise, you will learn how to add getters, setters, and methods. Instructions. Create an instance of the surgeon class. Set the name to Curry and department to cardiovascular. Save the instance to a constant variable called surgeon Curry. Okay, so we're going to have a const called surgeon Curry. It's going to equal the new keyword, the class we're calling it from. So we need a new surgeon, and we want to pass in Curry for the name, which is the first piece. And we want to pass in cardiovascular for the department. And that should do it. Save the instance because okay, let's try running that. That did work. Create an instance of the surgeon class, set the name to Durant and department to orthopedics. Save the instance to a constant variable called surgeon Durant. Okay, so now we're going to make surgeon Durant. So const surgeon Durant, that's a new surgeon. And we have to give him the name of Durant and the department of orthopedics. Save the instance. Okay, so let's run that, see if that's working. And that does work. Let's move on to the next lesson. Methods. At this point, we have a dog class that spins up objects with name and behavior properties. Below, we will add getters and a method to bring our class to life. Class method and getter syntax is the same as it is for objects, except you can not include commas between methods. That's something we learned before. These all end instead of commas with semicolons. So we have the class dog and we've seen the constructor. Now we're going to make a get name method. So it's going to be a get on a name method and that returns this.name. And then we'll have a get on a behavior method that returns this.behavior. And we have increment behavior method. There is no get or anything like that, but this.behavior ++. It increments it upward by 1 every time that it's called. In the example above, we add getter methods for name and behavior. Notice we also prepend our property names with underscores, name and behavior, which indicates these properties should not be accessed directly. Under the getters, we add a method named increment behavior. When you call increment behavior on a dog instance, it adds 1 to the behavior property. Between each of our methods, we did not include commas. Instructions. In the surgeon constructor, prepend the name and department properties with an underscore. Okay, so this underscore name, this underscore department, and we'll run that. That worked. So inside the constructor, add a property named remaining vacation days and set it equal to 20. Okay, so we have this dot, and it's pretty long. I don't want to make a typo, so I'm just going to copy it over. Remaining vacation days with an underscore in front of it, and it needs to be equal to the number 20. Let's run that. And we really should put our semicolons here as well, but that did work. Under the constructor, create a getter called name that returns the value saved to name. Okay, so under the constructor, here's where the constructor ends, and then we're going to have get name, and that is going to return the value saved in name. So return this dot underscore name. That should work. Let's see. That did work. Great. Under the name getter, create a getter called department that returns the value saved to department. Okay, so we have getter. It's going to be the same thing. So we have to change this to department. And that ought to work too. I'm going to put in my semicolons just to get this in my memory that these can't have commas, they have semicolons. Run that. Great. Under the department getter, create a getter called remaining vacation days that returns the value saved to remaining vacation days. Okay, so we need a remaining vacation days getter. Let's do that. Instead of department, it's going to be remaining vacation days. Okay, and let's try that. That worked. Under the remaining vacation days getter, create a method called take vacation days that accepts one argument named days off. Okay, let's do that first. So here's where it ends. And we want to make a get vacation. Oh no, it's called take vacation days. There it is. So we have take vacation days, and it's not going to have a getter just under the getter. So we're just having a method. And inside this method, we're going to subtract days off from the number saved to remaining vacation days. Then we'll set remaining vacation days to the result. Okay, so we have this. It's going to take in days off, and O has to be capitalized. And in the body, we're going to have to take this. So it'll be this dot remaining vacation days equals, and it would be this dot underscore remaining vacation days. Oh, I have two underscores. Minus days off. That looks like it should work. Let's give it a shot. And it does. All right, great. If you can't see this code well, maybe we could open this up for a sec. Okay, so this is what's happening. I know the equals kind of went to the next line, but this dot remaining vacation days is up here in remaining vacation days, and that's where we get it from this. And now we have to set it what it already is minus the amount of days off that were taken. So we're calling it again and making it equal to itself minus the days off that were taken. Let's go to the next lesson. Method calls. Finally, let's use our new methods to access and manipulate data from dog instances. Class dog, and it has the constructor, the getName, getBehavior, and increment behavior, and const Haley is equal to a new dog. In the above example, recreate the dog class, then create an instance and save it to a variable named Haley. The syntax for calling methods and getters on an instance is the same for calling them on an object. Append the instance with a period, then the property or method name. For methods, you must also include opening and closing parentheses. Let's take a moment to create two dog instances and call our .incrementBehavior method on one of them. Okay, so we'll have two dog instances. Let's take a look. There's letNico, and that's a new dog named Nico, and Nico.incrementBehavior, that will add 1 to Nico's behavior instance. Let Bradford equal new dog Bradford. Console.log Nico.behavior, that should log 1. Console.log Bradford.behavior, that should log 0. In the example above, we create two new dog instances, Nico and Bradford. Because we increment the behavior of our Nico instance but not Bradford, accessing Nico.behavior returns 1 and accessing Bradford.behavior returns 0 in instructions. At the bottom of main.js, use console.log to print the value saved to the name property of the Surgeon Curry object. So we'll console.log the name of Surgeon Curry. Okay, console.log Surgeon Curry dot name. Let's see what happens. Curry is the name. Call take vacation days on Surgeon Curry with an input of 3. Okay, so we will say Surgeon Curry dot take vacation days and pass in 3 there. All right, let's try that out. That did work. After you call to take vacation days, use console.log to print the value saved to the remaining vacation days property of the Sergeant Curry instance. So we want to see the remaining vacation days property now. So we just did the console.log name. We know how to do that. We will console.log again, Surgeon Curry, but not name this time. We want remaining vacation days, which is right here. I'm just going to paste that on in. Let's give that a shot. Nope, that is wrong. Did you call the remaining vacation days value from the Surgeon Curry instance? I have remaining vacation days with an underscore in front of it. Maybe not the underscore. Let's try that. That's what they wanted. They didn't want the underscore. They actually wanted us to get the remaining vacation days from this get. From this get here, remaining vacation days, that returns this dot remaining vacation days. And that's what we're able to console log there at 17. Great, let's go to the next lesson. Inheritance 1. Imagine our doggy daycare is so successful that we decide to expand the business and open a kitty daycare. Before the daycare opens, we need to create a cat class so we can quickly generate cat instances. We know that the properties of our cat class, name, behavior, are similar to the properties in our dog class, though there will be some differences because, of course, cats are not dogs. Let's say that our cat class looks like this. Class cat. There's a constructor with a name and uses litter. This dot underscore name is name. This dot underscore uses litter equals uses litter. This dot underscore behavior equals 0. We have a get name method that returns this dot name, a get uses litter method that returns this dot uses litter, a get behavior method which returns this dot behavior, an increment behavior method which increments this dot behavior up by 1 every time that it's called. In the example above, we create a cat class. It shares a couple properties, name and behavior, and a method, increment behavior, with the dog class from earlier exercises. The cat class also contains one additional property, uses litter. That holds a Boolean value to indicate whether a cat can use their litter box. When multiple classes share properties or methods, they become candidates for inheritance, a tool developers use to decrease the amount of code they need to write. With inheritance, you can create a parent class, also known as a superclass, with properties and methods that multiple child classes, known as subclasses, share. The child classes inherit the properties and methods from their parent class. Let's subtract the shared properties and methods from our cat and dog classes into a parent class called animal, class animal. It has a constructor that takes in name, and this dot name equals the name. This dot behavior will equal 0. We have a get name that returns this dot name, a get behavior that returns this dot behavior, and an increment behavior. So in both of these animals, dogs and in cats, they contain all of this. So this could be a superclass for both of them. In the example above, the animal class contains properties and methods that the cat and dog classes share, name, behavior, and increment behavior method. The diagram to the right shows the relationships we want to create between the animal, cat, and dog classes. We have a parent class of animal with properties, name, and behavior, and methods dot increment behavior. The child class of dog will take all of the parent's class properties and methods. The child class of cat will take all of the parent class's property and methods, and also add another property called uses litter. Let's go to the next lesson. Inheritance 2. In the last exercise, we created a parent class named animal for two child classes named cat and dog. The animal class below contains the shared properties and methods of cat and dog. And we went through all of that. So the code below shows the cat class that will inherit information from the animals class. So this is the entire cat class, and we did go through that already. To the right in main.js, you will put what you learned to practice by creating a parent class named hospital employee. Instructions. In the next few exercises, you will create two subclasses, doctor and nurse, from the parent class named hospital employee. Below, we have listed the properties and methods you will find in the doctor and nurse classes. Doctor. Properties, name, remaining vacation days, set to 20 inside the constructor. Insurance. Method, take vacation days. Nurse has properties name, remaining vacation days, set to 20 inside the constructor. Certifications. The methods are take vacation days and add certification. In main.js, create a parent class named hospital employee, add a constructor with name as an argument. Okay, so we need to make a class called hospital employee. And that is going to have a constructor. So constructor with the name as the argument there. And inside constructor, we'll set this dot underscore name equal to name. That looks to be what they want here because the property is underscore name. They didn't ask us to set it though. I'm going to get rid of this for right now. I'll just comment it out. Let's run this and see if it works. Yep, that worked. Inside the constructor, set the instance's name to name and remaining vacation days to 20. Okay, we did the name already. It's right here in this dot name. Let me indent, and then I want to have this dot underscore remaining vacation days. And that equals 20. And I will run that. Great. Under the constructor, create getters for your name and vacation days properties. Inside the getter, return the property's value. Okay, so we will make a get name, and that's a method. And in there, we're returning the property's value, this dot underscore name. And we need remaining vacation days as well. So get remaining vacation days, no underscore in front of it. And we make our method and return this dot remaining vacation days. Let's see if that's all right here. Let's run that. That works. Under the getters, add a method called takeVacationDays. This method should accept one argument, called days_off. Inside the method, subtract days off from remaining vacation days, save the result to remaining vacation days. So we're going to make a takeVacationDays method. takeVacationDays, that's taking in days off. And now we have to change it according to the days off. We have to change the remaining vacation days. So this dot remaining vacation days is going to equal this dot remaining vacation days minus days off. And that ought to work. Let's go ahead and run that. Great, we have that done. Let's move to the next lesson. Inheritance 3. We've abstracted the shared properties and methods of our cat and dog classes into a parent class called animal. And we just saw that, so let's move on to, now that we have these shared properties and methods in the parent animal class, we can extend them to the subclass cat. Class cat extends animal. Constructor takes in name and uses litter, and then calls super with name. This dot uses litter equals uses litter. In the example above, we create a new class named cat that extends the animal class. Let's pay special attention to our new keywords, extends and super. The extends keyword makes the methods of the animal class available inside the cat class. The constructor called when you create a new cat object accepts two arguments, name and uses litter. The super keyword calls the constructor of the parent class. In this case, super name passes the name argument of the cat class to the constructor of the animal class. When the animal constructor runs, it sets this dot underscore name equal to name for new cat instances. Uses litter is a new property that is unique to the cat class, so we set it in the cat constructor. Notice that we call super on the first line of our constructor, then set the uses litter property on the second line. In a constructor, you must always call the super method before you can use the this keyword. If you do not, JavaScript will throw a reference error. To avoid reference errors, it is best practice to call super on the first line of subclass constructors. Below, we create a new cat instance and call its name with the same syntax as we did with the dog class. Const Bryce cat equals new cat, Bryce, and false are passed in as the arguments there. Console.log Bryce cat underscore name, Bryce cat dot underscore name will output Bryce. In the example above, we create a new instance of the cat class, I imagine. So I'll read that one more time. In the example above, we create a new instance of the cat class named BryceCat. We pass it Bryce and false for our name and uses litter arguments. When we call console.log BryceCat._name, our program prints Bryce. In the example above, we abandon best practices by calling our _name property directly. In the next exercise, we'll address this by calling an inherited getter method for our name property. Instructions. In this exercise, you will begin to create the nurse class as a child of the hospital employees class. Remember, the nurse class has the following properties and methods. Nurse, properties, _name, _remaining vacation days set to 20 inside the constructor, and certifications, _certifications. Methods, .take vacation days and .add certification. Under hospital employee, create an empty class named nurse that extends hospital employee. Okay, so that was class nurse. Extends was the keyword, and then hospital employee. And that's all we have to do there. I think that's all they're asking for so far. Let's just run that. Yes, that's it. Inside the nurse class, create a constructor that accepts 2 arguments. Use the list of properties above to name these arguments. Okay, so they want us to use, we have name, remaining vacation days, and certifications. So we're going to make a constructor it accepts 2 arguments, so we'll need name and I imagine certification. And then in the body, we shouldn't do anything yet, I think. Let's just let's run this. Doesn't seem like we should do anything yet. Yep, that works. In the nurse constructor, call the parents constructor method and pass the appropriate values. Okay, so the parent constructor method was called with super, and the value that needs to be passed is only name. That's the only thing that happened in that constructor. Yeah, because this takes a name, and this dot name equals name. I think that would work. Let's see. Yes, it does. Inside of the nurse constructor and under super, set _certifications. Okay, so under super, we want to have this dot _certifications is equal to certifications. Let's run that. That does work. Under the nurse class, create a new instance of nurse and save it to a constant variable named nurse I don't know how to say this. We'll call her nurse O for now. Pass in the following values for each property. And we have a name and we have a certification, and that's an array. Okay, so let's work on that. Const and nurse O is going to equal a new nurse. And the new nurse takes in a name, which is this one right here that I'm having some trouble with, and that needs to be a string. And it also takes in certifications, which is right here, this array. There's our certifications array as the second thing being passed in, and let's run that and see if it works. There we go. Let's move on to the next lesson. Inheritance 4. Now that we know how to create an object that inherits properties from a parent class, let's turn our attention to methods. When we call extends in a class declaration, all of the parent methods are available to the child class. Below, we extended our animal class to a cat subclass. They have a class of animal that has everything animal had in it, and then they have a class of cat that extends animal, has a constructor. In the constructor, super is called with the name, and this dot underscore uses kitty litter is set to uses kitty litter, and they have a const of Bryce cat, a new cat named Bryce, who can't use litter yet. In the example above, our cat class extends animal. As a result, the cat class has access to the animal getters and the increment behavior method. Also, in the code above, we create a cat instance named Bryce cat. Because Bryce cat has access to the name getter, the code below logs Bryce to the console. Console.log brycecat.name. Since the extends keyword brings all of the parent's getters and methods into the child class, brycecat.name accesses the name getter and returns the value saved to the name property. Now consider a more involved example and try to answer the following question. What will the code below log to the console? We have brycecat.incrementBehavior, call.incrementBehavior on cat instance. Then we have console.log brycecat.behavior. Log value saved to behavior. The correct answer is 1, but why? The cat class inherits the behavior property, behavior getter, and the increment behavior method from the animal class. When we create the Bryce cat instance, the animal constructor set the behavior property to 0. The first line of the code calls the inherited increment behavior method, which increases the Bryce cat behavior value from 0 to 1. The second line of the code calls the behavior getter and logs the value saved to behavior, which is 1. Instructions. Call.takeVacationDays with an input of 5 on your nurse-o instance. So after everything, I'm going to grab nurse-o and nurse-o.takeVacationDays, and I'll pass in 5. Let's see if that works. Perfect. Under the method, call log the value saved to the remaining vacation days property in nurse-o. So we need to console log this one. Console.log and her remaining vacation days. Perfect. We have 15 left after that. Let's move on to the next lesson. Inheritance 5. In addition to the inherited features, child classes can contain their own properties, getters, setters, and methods. Below, we will add a useLitter getter. The syntax for creating getters, setters, and methods is the same as it is in any other class. And they have the cat class extending the animal class, which we've seen several times. It does have a getter in here, get, and then the useLitter method. In the example above, we create a useLitter getter in the cat class that returns the value saved to useLitter. Compare the cat class above to the one we created without inheritance. And we can see this class of cat has everything that was inherited now in it itself here. So we decreased the number of lines required to create the cat class by about half. Yes, it did require an extra class, animal, making the reduction in size of our cat class seem moot. However, the benefits, time saved, readability, efficiency of inheritance grow as the number and size of your subclasses increase. One benefit is that when you need to change a method or property that multiple classes share, you can change the parent class instead of each subclass. Before we move past inheritance, take a moment to see how we would create an additional subclass called dog. Class dog extends animal. Constructor, name, super, name. The dog class has access to the same properties, getters, setters, and methods as the dog class we made without inheritance and is a quarter the size. Now that we've abstracted animal daycare features, it's easy to see how you can extend animal to support other classes like rabbit, bird, or even snake. Instructions. Use the properties and methods below to help you complete the tasks that follow. Nurse has a property name, remaining vacation days, set to 20 inside the constructor, and certifications. Methods take vacation days, add certification. Under the nurse constructor, add a getter that returns the value saved to the nurse instance's certifications. Okay, so we're going to make a getter under the nurse constructor, which is right here. There's a constructor. A getter starts with get, and we want to get the certification. So we will use the word certifications here, not the underscore though. I'll get rid of that. And so this will be a method that returns, so return this dot underscore certifications. All right, that should work. Let's try it out. Perfect. Add a method called add certification under the certifications getter. The method should accept one input, new certification. Let's do that first. Add certification is a method that takes in new certification. Inside the method, use the push method to add the new certification value to the nurse's certification array. Okay, so now we'll have the new certification value pushed in there. So we'd have this dot underscore certifications dot push, and we want to push the new certification into there. Yep. Make sure you get it in there. There we go, and I will run that. Let's see. Perfect. At the bottom of main.js, call the .addCertification method on nurse O with a parameter of genetics. Okay, so after everything, we know we have nurse O right here. So nurse O dot, and it was add certification, and what we want to add there is genetics. So capital G, genetics. And let's run that. Log the value saved to the certifications property of nurse O. Okay, in order to log a certification, we have this get certifications right here. So we got to start nurse O up again, and we will do dot certifications. And we could just run that. Oh, no, I have an error because, I should have logged it and I didn't. All right, little mistake there. So console.log, and let's stick nurse O's certifications in there and try again. There we go, we have trauma, pediatrics, and now genetics. Let's move on to the next lesson. Static methods. Sometimes you will want a class to have methods that aren't available in individual instances, but that you can call directly from the class. Take the date class, for example. You can both create date instances to represent whatever date you want, and call static methods like date.now, which returns the current date, directly from the class. The .now method is static, so you can call it directly from the class, but not from an instance of the class. Let's see how to use the static keyword to create a static method called generateName method in our animal class. It's just going to be called generateName. It's not generateName method. So we have a class of animal and the constructor, of course. Now here we are in the static generateName. So there's a static method right here, and we have a const names equals an array of names. Const random number will equal math.floor, math.random times 5, since there are 5 names, and then you return name, open square brackets, and put that random number inside of there to return one of the 5 names at random. In the example above, we created a static method called .generateName that returns a random name when it's called. Because of the static keyword, we can only access .generateName when appending it to the animal class. We call the generateName method with the following syntax: console.log animal.generateName, and we have to invoke it. You cannot access the generateName method from instances of the animal class for instances of its subclass. See below. Const Tyson equals new animal and the string of Tyson. Tyson.generateName would give you a type error. The example above will result in an error because you cannot call static methods generateName on an instance Tyson. Instructions. Inside of your hospital employee class, create a static method called generatePassword. When it's called, this method should return a random integer between 0 and 10,000. So we want to make a generatePassword method. So the first thing we should do is let's make the method. GeneratePassword, and it needs to be static. So before it, we write static GeneratePassword. And inside of there, it should return a random integer between 0 and 10,000. And we could grab that right from what they did. See here, so math.floor will round down anything that it receives. And inside math.floor is math.random, generating a number between 0 and 1. We multiply that number by 5 here, and then we floor it to make sure we have something between 0 and 4. Since there is 0, 1, 2, 3, and 4. So let's take this random number here, const random number, and we'll put it in here. And we don't need to return names or anything. So I'm not going to even have a const called random number. I'm just going to return a random number. And they want it to be between 0 and 10,000, so it really should be probably 10,000. Do they want it to include 10,000 is really the question now. So I'm just going to make it 10,000 and see what happens. Oh, did I close this properly? I did not. So make sure that that is there. That closes the function, and this closes the class. So let's run it. That works, great. We can move on to the next lesson. Review, classes. Way to go, let's review what you learned. Classes are templates for objects. JavaScript calls a constructor method when we create a new instance of a class. Inheritance is when we create a parent class with properties and methods that we can extend to child classes. We use the extends keyword to create subclasses. The super keyword calls the constructor of a parent class. Static methods are called on the class, but not on instances of classes. In completing this lesson, you've taken one step closer to writing efficient production-level JavaScript. Good luck as you continue to develop your skills and move into intermediate-level concepts. And we have instructions for some extra practice if you'd like to do it, but let's see what's up next.